Hi everyone. When we write lab reports, we are going to sometimes have some errors from the lab that we'll need to evaluate in how they determine the final thing that we calculated in each lab report. So I can't talk exactly about today's lab. I don't want to give you all the answers today, but I can talk about something similar, titrations. We will be dealing with titrations 2 weeks from now, regardless. So in a titration, you might want to determine the molarity of a analyte solution. You can do this by using a known molarity titrant solution. So for example, you might know the molarity of this acid solution here, and you add it, drip, 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 to the base solution. You add it until you get a color change. At that point, you would have added just enough moles of the acid to react with the moles of base present down here. And that would allow you to determine the molarity of the base solution down there. So with most of our titration experiments, we want to go into our happy place, the land of the mole. You can get to the molarity of the base by having the molarity, the volume of the acid. So you know the milliliters of acid that you added, and hence the liters of acid that you added. And knowing the molarity of the acid solution, you might know how many moles of acid were present. And then you can determine how many moles of base were there reacting with the acid. And from that, the molarity of the base. So we, though, want to see what effect we might have if we accidentally add too much of this. What effect will it have on the molarity of the base? So we can determine whether each of these steps, each of these arrows, is going to show a direct or inverse relationship by actually going back into the calculations. So for example, to determine the number of liters of acid that were needed to neutralize the base, we could see the number of milliliters of acid that were needed to neutralize the base. If milliliters were too high, then the liters of acid would be too high as well. There is a direct relationship between these. If you plugged in a number here, you might get a certain number here. But if you doubled this number, you should double that number. Direct relationship between these two things, so they both go up. And then what effect does having too many liters of acid have on the moles of acid? All right, so you know molarity is equal to moles over liters, i.e. Moles is equal to molarity times liters. If too many liters of acid were needed to neutralize the base solution, then too many moles of acid would be needed to neutralize the base solution. So during our experiment, there should be a certain number of moles of acid needed to neutralize the base, but because you added too many liters of acid, you might calculate that there an accidentally higher number of moles of acid were needed to neutralize the base. Anyway, there's a direct relationship here. Increase this one, increase that one. Okay, so increasing that increases that. And then we can see a direct relationship between moles of acid and moles of base because to get it from moles of acid to moles of base, you might multiply by a 1-to-1 or 2-to-1 or 1-to-2 ratio. But regardless, if you have a higher value here, you'll have a higher value here. And then you can calculate the molarity of the base solution from moles divided by liters. There is also a direct relationship here. If you think there are too many moles of base present there, so if the value of moles of base there is artificially too high, then your calculated molarity of the base will be artificially too high. All right, so if I could kind of summarize what you might want to say as you write the lab report, it might be that during the experiment, you might have accidentally added too many milliliters of acid, perhaps because you kept adding them after you got color change. Now, having added too many milliliters of acid solution, you are going to artificially get a higher calculated molarity of the base. So in reality, the molarity of the base solution might be 1.0 molar, but because of this error, you might calculate it to be 1.1 molar. The calculated version is artificially too high. This is because the milliliters of acid is directly related to the liters of acid. And the liters of acid is directly related to the moles of acid. And the moles of acid is directly related to the moles of base, and that is directly related to the molarity of the base.